Okay, welcome to this video. In this video we're going to learn about counting subsets. So we're going to consider the set 1, 2, 3. So this is a set with 3 elements in it. The numbers 1, 2, and 3. I want to list all subsets of 1, 2, 3. So first I'll list the subsets with just one element. So one element subsets. So remember, a subset is a set whose elements are also in the original set. So if I just want one element, well, I could have the set with just the number 1. Right? So 1 is also in this set, so it's a subset. The set with just the number 2. And the set with just the number 3. I can also do the same for 2 element sets. So I need 2 elements, both that are in here. So 1, 2, 1, 3, and 2, 3. And now a lot of people, they think, okay, that's it, done. That's all the subsets of this. So they think there's 6. But there's 2 extras that you might not recognize. One of those is the set with 3 elements. So 3 element set would be, well, it's the set itself, 1, 2, 3, and you might be saying, well, why is that a subset? That's just the original set, but it fits our definition of a subset. A subset says that all the elements in this set must also be in this set, and that's true. These numbers, or these elements, are all in the original set, which makes it a subset. So it's true that every set is a subset of itself. And sometimes we'll make a distinction, and we'll talk about proper subsets. And in that case, we'd basically just exclude the case where the set is an element of itself. But we're not really going to make that distinction. We're just going to say a set is a subset of itself. And then the other one that you might not be thinking of, and you might not even recognize this as a set, is a set with 0 elements. And well, what does that set look like? Well, it's just a set with nothing in it. And you might be saying, well, how is that? Well, actually, before I say that, I'm just going to define this. This is a special set which we call the null set. So it's a set with no elements. So the set so we often represent it just by squiggly brackets with nothing in it, or sometimes we use a special symbol. It looks like a 0 with a dash with a line through it. You might be saying, well, how is that a subset? In a subset, don't the elements have to be in the original set? And yes, that's true. But if you think about it, it doesn't fail to meet those conditions. So the conditions of a subset say that everything in this set must also be in this set. Well, if nothing's in this set, then you can't say that the elements here are not in here. Right? It's true that the elements here are not in here. But you can't say that there's any element in this set which is not in this set. So it doesn't technically fail to meet the conditions of a subset. So we say it actually does meet them, even though it's a little strange to think of, but it does fit our definition. So it's true that the null set is a subset of every set, because none of the elements in the null set are not in the original set, so it meets the conditions. So if you count them up, we had 8 subsets. And just another way to think about this, we could have done this using combinations. So remember, combinations mean you're really counting subsets, right? In this case, we have 3 elements to choose from, the numbers 1, 2, and 3, and we're choosing one of them at a time, which is just 3, and that would be these 3 sets. Same with 3C2, so you had 3 elements to choose from, and you're choosing 2 of them at a time, and again, that would be these 3 sets. And here you'd have 3 elements to choose from, and you're choosing all 3, so it'll be 1. And over here, 3 elements to choose from, and you're choosing 0, which is again 1. So if you add all these numbers up, you would get 8. So therefore, there are 8 subsets. Okay. Now, that's the type of question we're going to want to answer. How many subsets does a set have? Well, doing it this way every time that would be too much, right? Here we had 3 elements, and we listed all the subsets. But if we had 10 elements, there's no way you want to list all the subsets. There's no way you even want to do this combination thing where you're doing let's say it had 10 elements. You don't want to do 10C0, 10C1, 10C2, etc. It's too much. So we're going to do this by the fundamental counting principle. It's another way to do this question. It's much quicker. So think about making a subset of 1, 2, 3. So fundamental counting principle is where we break it into actions. So my first action will be around the 1. I'm going to say, should I choose the 1 or not? Action 2, should I choose the 2 or not? And action 3, should I choose the 3 or not? So by the fundamental counting principle, I will just multiply all the possibilities for these actions. Action 1, I could choose a 1 or I could not choose it. So that was just 2 possibilities. Action 2, again, 2 possibilities. And action 3, 2 possibilities, which would be 2 to the power of 3 or 8, which was the number of subsets. Just to illustrate this even further, we could do this by a Venn diagram. So action 1, remember, was choosing the 1 or not. So we'll say yes 1 or no 1. Action 2, yes 2, no 2. Yes 2, no 2. And action 3 would be yes 3, no 3, yes 3, no 3, yes 3, no 3. So you can see there's 8 branches here, and you can even write the sets down for each branch. This top branch was yes 1, yes 2, yes 3. So that was the set 1, 2, 3. The second branch was yes 1, yes 2, but no 3. So that'd be 1, 2, but not the 3. Then we have a 1, no 2, yes 3. So 1, 3. Then we have a yes 1, no 2, no 3. So just 1. No 1, yes 2, yes 3. So that's 2, 3. No 1, yes 2, no 3. No 1, no 2, yes 3. And then the last one, no 1, no 2, no 3. That was the null set. So these 3 sets are the subsets. which is basically listing them again, so you wouldn't want to have to do the tree diagram. But we know we can do tree diagram questions just by using the fundamental counting principle, which is multiplying all the possibilities, which is what we did here, and we got 8. So this is a quicker way to do this question, counting all the subsets without using combinations and without listing them all.